We're going to talk today about solving systems of linear equations. This is a very big topic when it comes to word problems, etc. And so I want to focus on the foundations, the basics of it, which is the addition method. There's also the substitution method, but I personally use the addition method whenever I can. Now the addition method is very simple. You put your two equations in standard form. Standard form is ax plus by equals c. And in this case, what you're trying to do is you're trying to look for their pair of variables, either your x's or your y's, that have opposite coefficients. So in this case, I have 3 and 2 for my variables for my x's, but I have -1 and +1 for my y's, so they're already opposites. So I've accomplished what I wanted to already. So what I'm going to do is, since they're opposites, they're already lined up, the x's over the x's, the y's over the y's, and the constant over the constant, I'm going to simply add these two equations. When I add 3x plus 2x, I get 5x. Now notice when I add the y's, the coefficients are opposite. So -y plus y is 0y, so the y literally falls out of the equation and disappears. And 5 plus 5 is 10. Now I have a very nice equation, 5x equals 10. And I divide both sides by 5, I get x equals 2. Now the part we need to make sure we don't mess up on here is to think we're done, because we're not. Remember, when you're solving systems of linear equations, I have two variables. Therefore, my answer is a point. It has to have an x-coordinate and a y-coordinate. So I need to go back and take one of these equations. In this case, I'm going to take the top one, the 3x minus y equals 5. And I'm going to plug in that 2 I got for my x. And when I do that, I get 6 minus y equals 5. I subtract 6 from both sides. I get -y is -1. So y is 1. So therefore, I got x equals 2 up here. I got y as 1 down here, so I get 2, 1 for my final answer. Now, this was a very simple equation because we started out, they were opposites. We come down here to a second example, 4x plus y equals 14, and 3x plus 2y equals 13. Well, they're not opposites. I have 4 and 3 here, and 1 and 2 there. What I need to do is make them opposites. So I look at the 4 and the 3, and I look at the 1 and the 2, and you want to think of least common multiple, or which is really akin to your LCD. The least common multiple of 4 and 3 is 12. The least common multiple of 1 and 2 is 2. In other words, that's the smallest number that's a multiple of both numbers. So I'm going to choose the 2 part, because that's the smaller of the two least common multiples. Well, this one's already a 2, so I'm going to leave it alone. I'm not going to do anything to it. I'm just going to take it and rewrite it here. I want this to become a 2, but not just a 2, I want it to become a -2 because I want them to be opposites. So I'm not just going to multiply this one by -2, I'm going to multiply the entire equation by -2. So 4x times -2 is -8x, y times -2 is -2y, and 14 times -2 is -28. Now I have the situation I want. I line them up in standard form. My y's are opposites, which means I can add because that will cancel the y's. -8x plus 3x is -5x, -2y plus 2y is 0y, and -28 plus 13 is -15. Now I have a very simple equation. Divide both sides by -5. I get x equals 3. Again, I'm not done. I need to go back and pick one of my original equations. We could pick one of the other equations, but I think it's always best to try to use one of your originals. That way it reduces the possibility of a mistake. I'm going to pick the 3x plus 2y is 13. I'm going to plug in 3 for x. I get 9 plus 2y is 13. 2y is 4. So that gives me y is 2. So my answer is 3, 2. Now, why is the addition method so great? Well, I love it because it allows me to deal with fractions as well. I'm going to start out with these two ugly equations. 1/4 x plus 1/3 y equals 4. And 1/2 x plus 5/3 y equals 14. Now, the reason I like the addition method is that it allows me to get rid of my fractions. We're going to do that like we've always done. I'm going to look at my first equation. My denominators are 4 and 3, so my LCD is 12. My second equation, my denominators are 2 and 3, so my LCD is 6. And what I'm going to do is multiply my top equation, everything by 12. So 12 times 1/4 is 3, so that's 3x. 1/3 y times 12 is 4y, and 4 times 12 is 48. So that gives me an equation of 3x plus 4y is 48. Same with my second equation. I'm going to multiply by 6. 6 times 1/2 x is 3x, 6 times 5/3 y is 10y, and 6 times 14 is 84. Now this gives me my new set of equations. 3x plus 4y is 48. 3x plus 10y is 84. Please notice here, I've basically got equivalent systems of equations but without any fractions. Now I'm just going to pick it back up with what I've been doing. I'm going to try to make a variable opposite. Well, in this case, my x's are they're both 3's. So really I just need to change one of them. So I'm going to leave the top one alone this time. I'm going to multiply the bottom one by -1. I could have multiplied the top one by -1 as well. It didn't matter. In this case, I'm just going to do the bottom one. So basically multiplying -1 by times my bottom equation just changes all the signs. So it becomes -3x minus 10y is -84. Notice the 3's now cancel. The x's, the 3x and the -3x, add up to 0. So positive 4y minus 10y is -6y. 48 minus 84 is -36. So you get y is equal to 6. Notice this time I solve for the y. You can do either one. Simply pick the easiest one. Now I'm going to go back in and pick one of my equations with my fractions. 1/4 x plus 1/3 y is 4. Plug in 6 for y. I get 1/4 x plus 2 equals 4. So 1/4 x is equal to 2. And then I multiply both sides by 4, get x equals 8. So my answer is 8, 6. Give these practice. They'll take some time, but I think you'll catch on and see how great the addition method is. We're also going to do word problems, and the key in word problems isn't really the addition method, it's figuring out the actual equations. Best of luck.